Mindset Show!
Hello and welcome back to the GCP Mindset Show. Today we'll test your knowledge about one of the most crucial topics in clinical research, biostatistics.
Why did the biostatistician break up with the clinical researcher? Because she said their relationship was not statistically significant and had a low power to continue. But let's get serious again. Today I have 5 questions for you from the field of biostatistics and clinical research. So, sit back and test your knowledge. Good luck, and let's go. Question 1. In the context of biostatistics, what is the fundamental difference between a variable and a parameter? A. Variables are qualitative descriptors, for example, gender, while parameters are exclusively quantitative measurements, for example, height. B. Variables are quantities that vary between individuals, for example, blood pressure, while parameters are computed quantities defining a theoretical model, for example, mean difference. C. Variables are theoretical values assumed for the population, while parameters are the specific measurements collected during the trial. And the correct answer is B. A variable is a characteristic measured on each individual, for example, blood pressure. It can take different values from person to person. A parameter is a numerical characteristic of the population or statistical model, for example, the true mean blood pressure or the true mean difference between treatment groups. The parameter itself is not observed directly. It is estimated from the sample data using statistics, like sample means or sample mean differences. Let us continue with question 2. In hypothesis testing, what does the alpha error, type 1 error, specifically represent? A. The probability that the null hypothesis is true given the observed data. B. The probability of falsely rejecting the null hypothesis, finding an effect when there is none. C. The probability of falsely accepting the null hypothesis, failing to detect an effect that actually exists. And the correct answer is B. The alpha error, or type 1 error, is the probability of a false positive, concluding there is a difference or effect, rejecting the null, when in reality the null hypothesis is true, no effect exists. Got everything right so far? Let's move to question 3. Why is a confidence interval often considered more clinically useful than a p-value alone? A. Confidence intervals calculate the probability of the alternative hypothesis being true, whereas p-values calculate the probability of the null hypothesis being true. B. Confidence intervals eliminate the risk of type 1 errors, whereas p-values cannot account for type 2 errors. C. Confidence intervals provide the range and precision of the estimated effect size, whereas p-values only indicate statistical significance against the null hypothesis. And the correct answer is C. A p-value tells you how compatible your data are with the null hypothesis and is typically used to decide whether a result is statistically significant, but it does not show how large or precise the effect is. A confidence interval, in contrast, shows the estimated effect size and its uncertainty. For example, that systolic blood pressure is reduced by 5 to 10 millimeters of mercury. This helps clinicians judge both statistical significance and clinical relevance. Let's move on to question 4. How does high variability in the data affect the sample size required to verify a mean difference with 80% power? A. It decreases the required sample size because extreme values make the effect more obvious. B. It significantly increases the required sample size. C. It has no effect on sample size, provided the alpha error remains constant. And the correct answer is B. Formally, power depends on the standardized effect size, mean difference divided by standard deviation. When the standard deviation increases but the true mean difference stays the same, the standardized effect size shrinks, so we need more subjects to reach 80% power. And now the last question for today, question 5. In the context of sensitivity analysis for missing data, what is the primary purpose of a tipping point analysis? A. To identify the specific assumptions about missing data, for example, responder rates, under which the study's conclusion flips from significant to non-significant. B. To calculate the maximum number of protocol deviations allowed before the intent to treat ITT population must be replaced by the per protocol PP population. C. To determine the exact point in participant recruitment where the statistical power reaches a threshold allowing for early trial termination. And the correct answer is A. A tipping point analysis systematically varies assumptions about outcomes for patients with missing data, often separately in each treatment arm, to find the point at which the trial's main conclusion, for example, statistically significant benefit, would change. If that tipping point requires highly implausible assumptions, the findings are considered robust to missing data. That's it for today. So, did you answer all the questions correctly? Let us know in the comments. Don't forget to like, comment, and subscribe to our channel. See you next time with new questions about clinical research. Until then.